Welcome to Anything Maths. This video deals with deriving all the equation for motion under constant acceleration, also known as 𝐶𝐬𝐧 by many of you students out there. Like the video and subscribe. Before we go into the derivation, there are some few things we want to take note of, the symbols that we're going to use. S is going to stand for displacement, but sometimes, as we've seen from previous videos, displacement can also be the same as distance. So it depends on context, really. So read the questions really well. And we have U is going to be the initial velocity, V the final velocity, T always the time, and we have A acceleration. We have velocity time graph, and we're going to assign it some kind of velocities and some kind of labels so that we'll be able to use it. The first thing we want to do is we want to put 0 here and make the assumption that the object is moving with initial velocity u. Okay, and the final velocity is v. So the final velocity is the final velocity, and it travels for t seconds. So this point is t, travel for t seconds. So initial velocity, final velocity, and travel for t seconds. We also want to find the gradient of this graph. So in order to do that, we can construct some kind of like a triangle. The change in velocity is v minus u according to the graph, and the change in time is t, because t minus 0 will be t. The question though is, what is the gradient? How do you define the gradient? From our previous knowledge, we know that gradient is equal to the change in velocity over change in time. However, on the velocity time graph, the gradient is acceleration. We can confidently say this is equal to A. If you've not watched the previous video, please do so. By means of cross multiplication or any technique that is really convenient to you, we can say V minus U should be equal to 80. And making V the subject of the formula, we then have V should be equal to U plus 80. This is one of the most fundamental equations. What does it tell you? It says we can express the final velocity in terms of the initial velocity plus the product of the acceleration and time. So if we are given these information, then we can easily find the final velocity. In essence, if we are given 3, we will always be able to find the 4th parameter in this equation. So this is one of the most important equations. Let's look at the second one. The next thing we want to find is the distance traveled. In this case, the distance traveled is also the displacement. So be careful when you are dealing with these sort of questions. From the previous video, the distance traveled is the area under the graph. This is the area under the graph. And let me put a point A here. So U, O, U, A, and T. What kind of figure do you see? I'll shade it a bit so that you see. It's a trapezium, isn't it? So we're going to use the idea of finding a trapezium, the area of a trapezium. Then we equate it to S. So the area is going to be half U plus V times the height. And we know, as far as the velocity time graph is concerned, the area under the graph is displacement or time distance covered. So it's going to be X. And as a result, we can confidently write S is half U plus V times T. So the displacement or the distance is being expressed in terms of initial velocity, final velocity, and time. That also means if you knew any three of those quantities, you can always find the fourth one. Now the next three equations, they are going to be based on these two equations we've already derived. So let's see how we're going to work with these two equations. Now we have the two basic equations. What we want to do now is to express the distance or the displacement in terms of initial velocity and time. That will mean we substitute 1 in 2. We can put equation 1 in 2. That's exactly what we're going to do. And so we're going to have S should equal to half U, but instead of V, we're going to write U plus AT times T. And this will become 2U plus AT times T. Expanding, we're going to get UT plus half AT squared. It implies S is UT plus half AT squared. Nice. We've been able to express the displacement or the distance in terms of the initial velocity and the time. So if we don't know the final velocity, we can still find the displacement or the distance. Remember, depending on context. Okay. Next, we want to express the displacement or the distance in terms of the final velocity. Let's look at how we're going to do that. From equation 1, we're going to make V the subject of the formula. We can write, we're going to make U the subject of the formula. So we can write U should equal to V minus AT. We can label it equation 3. What we're going to do is put equation 3 into equation 2. So put 3 in 2. It becomes S half instead of U, we write V minus AT plus V times T. We're going to have half 2V minus AT times T. Expanding, we're going to have S equal to VT minus half AT squared. So what we've been able to do is we express this displacement in terms of the final velocity and the time. So we don't need to know the initial velocity. Once we know the final velocity and the time spent, we can calculate the displacement or the distance. Always read the question carefully. But that determines whether S is a distance or displacement. Let's look at the final one. We want an equation that has no t in it. So what we're going to do, we're going to make t the subject of the formula from equation 1. From 1, we can write t v minus u all over a. So let's put a bracket around it. And let's call it equation 3 as well. And we put 3 in 2. And x becomes half into bracket v plus u. Instead of t, we put v minus u over a. And this becomes half a v plus u v minus u. And you can see that this is a difference of 2 squares, isn't it? It's a difference of 2 squares. So we can write this x as half a times v squared minus u squared multiplied through by 2a. We're going to get 2as should be equal to v squared minus u squared, making this v squared the subject. Go to v squared should be equal to u squared plus 2as. So now we don't have any t here. We can easily find the final velocity if we knew u, a, and x. This is really important. According to the syllabus, you should be able to derive all the 5 equations. You don't know when this question is going to be asked in the exams. The best way to do it is to prepare for it. Watch the video several times so that you'll be able to derive these 5 questions. This is the end of the video. Like it and also subscribe to the channel.